Here we have the table of values from question number 1. The only difference in the y values here, you see that it's been input as negative 15 quarters, but Excel writes it as a decimal. Same thing here, negative 7 halves. So we want to calculate the first differences. We know to do that we must take this number, this y value, negative 3.5, and subtract the first y value. In Excel, what we do is we put in a formula. We always start it with an equals, and we tell the computer or the Excel program where to find negative 3.5. It is in cell B3. So we type in B3 minus, and where to find negative 3.75, that is in cell B2. So there's our first difference, subtracting these two y values. Now using Excel, I can just copy that formula all the way down, and I have all of my first differences. What's nice about working in Excel, the same formula applies to second differences. So I can take this formula and copy it over to here, and now copy this all the way down. So you'll notice two things. Here the formula says B3 subtract B2. Here the formula says C3 subtract C2. And you notice for this exponential function, the first differences are identical as the second differences. So that's a special feature of exponential functions. Our second question was, what if we work backwards? What if we were told all the first differences were 4? What might the table of values have looked like? Here I've set up the x values between 0 and 7. I can pick any y values I want. So let's start at negative 8. I just have to, I don't want it here, I want it up here. Start at negative 8. I just have to make sure that these y values go up by a value of 4 every time. So again, the beauty of Excel, I can put a formula in here. Equals, notice the formula appears up here as well. B2, that's my first y value, plus 4. Negative 8 plus 4 would be negative 4. I can copy that formula all the way down, and I can see all my y values go up by 4. So there's a possible table of values for all the first differences of 4. If I'd started somewhere different, suppose I started here at 11, all I have to do is press enter and all my values change because I've used a formula in every one of these rows. And here's where the formula appears that I'm always going to add by 4. And the last question 3, what level differences would I need to calculate for a cubic function? Our cubic base function is y equal x cubed. So we have a power function in Excel. Power is the same as an exponent, a cubic function. I know I'm going to cube negative 3, cube negative 2, cube negative 1. So I've used this formula. I've told the computer or the software where to find the first value in A2, and this comma 3 means I want to cube it. And I've copied that all the way down. Similarly, I could have said equals A2 times A2 times A2. I get the same value, copy that all the way down. So I want to calculate my first differences. Remember, this value, negative 8, subtract negative 27. So where do I find negative 8? In B3. So B3 minus B2, oh, it didn't give me a value. What did I forget? Let's see. I didn't put an equal sign in front. The equal sign means do the calculation with the two values in here. So B3 minus B2, and I copy these down. Again, I can copy this formula over to here, and there's my second differences. So far I see a pattern. I have similar values going up, down, and then up. Same thing here, similar pattern. Let's calculate the third differences. I'm going to move over my textbooks. Let's calculate the third differences. So I'm going to copy this formula over to this cell and get this little plus sign. There, third differences for a cubic are all equal. That makes sense. It's a cubic, the third differences are equal. For quadratic, the second differences are equal, and as we saw in question 2, for a linear, the first differences are all equal.